You what a regular polygon is. We know all sides are congruent and all angles are congruent. Okay, so here's an example of a regular pentagon. Okay, I'm just using this one. Right, but there are different types of polygons, right? There are octagons, there are hexagons, pentagons, squares. So you have different types. No, not a rectangle. Okay, so this is just an example because I got to start somewhere. Okay, what we want to do when we have a regular polygon is picture that you have the center of this polygon, kind of like the center of the circle, where that center point is equidistant from like the vertices and of the sides. So if you draw a segment from the center to each vertex, so go ahead and do that.
I think you won't do that in circles.
Imagine if the pentagon was inscribed in a circle, each vertex would be
Congruent.
okay. So what can you say about all of the triangles? They're two congruent, and there's one more.
Equiangular.
They're not equiangular. Okay, not equilateral. What's the one where, look at each side. Okay, guys, let's think before we just call out. There are two sides congruent.
Isosceles.
I said that.
You just weren't loud enough. Sorry.
I heard you say it, Allie. It's just everybody else was calling out wrong answers, so it kind of just... Okay, so they are congruent and isosceles. Now, what we're going to have to do is we're going to have to figure out the central angle of a regular polygon. So what we do is we take 360 divided by the number of sides. So just as an example, what we're going to do is we're going to take the central angle is 360. So if it's a pentagon, there are 5 sides. So we get 72. So that means each central angle in here is 72 degrees. Okay? Can you kind of picture that? So this is for any polygon. We're going to take 360 divided by the number of sides. So this is just for a pentagon. So let's say we had a hexagon. If you took 360 divided by 6, each central angle would be 60 degrees, right? 360 divided by 6. So depending on how many sides will determine the measure of the central angle. Okay, so we have a new term here called the apothem. Apothem. Okay, so it's the segment from the center perpendicular to a side. Now it doesn't really matter which side we draw it to because the apothem is going to be the same no matter where we draw it. So it's basically the height of any one of those triangles that we have there. We're going to use the lowercase a to represent that. So kind of picture any, so drawing from the center, if you drew perpendicular to any side, that length will be the same, right? So if I were to draw it here, that will still, those are going to be the same. That's still an apothem.
Wow, that's
Okay.
so cool.
Now, what happens when we draw the apothem within one of those isosceles triangles? What's going to happen to that central angle?
45, 45, 90.
Whoa, I don't know where we're getting those numbers. Hold on.
A lot.
Okay, slow down. Just before you call out, this is what you guys need to work on.
We're gonna have more time.
Before you call out, you have to like think before calling out those answers. Okay, let's work on it. Work on it. So let's think.
Right
Maybe we'll even raise our hand this time.
We're gonna have 5 more times.
If you have 72 degrees,
36. No, that's wrong.
It's 90 degrees.
okay, this is 90 degrees, but what about the angle up here?
Oh, it's half.
It's half.
Oh,
So,
we're trying to figure out. That's really simple.
I am so done with our class.
I love our class so much. I like it when it's just us.
Yeah.
I'm like Friends 2.0.
Wait, next year?
Oh, okay.
Next year? Loves our class.
so let me just rephrase. This is an octagon. I just have another picture. Here's the apothem. See, so these two angles inside are going to be congruent, okay? Also, not only that, but these two sides are going to be congruent.
Oh,
Right?
like, what's it called?
Because
Altitude.
so the apothem is going to be the altitude of the isosceles triangle. So it's going to split that isosceles triangle into two right triangles. Okay, now think about the area. Think about the area of one triangle. Okay, so base times height divided by 2. Now look at what we have here. What's our base? It's essentially one side length. So that would be S. And then times A divided by 2, right? Because the height of this triangle is A, the apothem. 1/2 base times height. Yeah, you could do or 1/2 S times A. Now let's say that's just one triangle. So what would you do to find the entire figure? How many triangles do you have? 8. Okay, so times 8. So think about that. So here's our actual formula that we're going to use. That's if you had to find one triangle. But what if you want to find the whole figure? We're going to use 1/2 times the perimeter times the apothem. Think about that for a minute. Why we use perimeter instead of... Now, could you figure out the area of one triangle and then just multiply that by how many you're going to have? But that's really, think about perimeter. Perimeter is going to be the number of sides times the side length. So that makes sense, right? And the last one we said times 8. It's the number of sides times the side length. So, for example, what... Yeah, and this...
Oh, cool.
So it's P times S.
No, it would be
times
the number of sides, n times s. Or sorry, n times,
A. So it would be
yeah, n times s. Right, so like if each side was 10,
So it's N times S equals 8. Oh.
Wait, what's N?
n is just the number of sides. N usually represents the number of sides.
Remember when we did it?
Okay, on the next page, I tried to write out some steps, just so you know, sometimes the steps are kind of interchangeable, so like 3 and 4 can be drawn differently. Okay, so the first step is actually done for you in example 1. It says draw one triangle from the center to 2 consecutive vertices and find the central angle. Now let's look at example 1. We'll read the steps as we do this problem together. So the central angle here, notice I gave you a pentagon again, so if you don't remember, it's 360 divided by the number of sides. So we get 72. So that means this angle here, angle NPM, is 72. So that's just step 1, is figuring out the central angle. Step 2, draw the apothem and bisect the central angle. Well, the apothem is already drawn. What would be half of that angle? 36 degrees. So right in here is 36 degrees. Can we see that? Now, number 3 and number 4 could be used interchangeably. It says use SOHCAHTOA or special triangles to find any of the missing measures or find the perimeter if not given. Because remember, what's our formula? Our formula is 1/2 perimeter times the apothem. But we were given the perimeter. So what do we need to find? The apothem. Okay, Allie. So perimeter is 40. Okay, so here's what did I say for step 3, guys? We're missing step 3. Use SOHCAHTOA or special right triangles.
What's special? We don't know.
So,
Side is 8, so you can just do 4. And
okay, so here,
under it is 4, so then you can just find that.
so basically what we're doing is we're taking a right triangle and solving for what's missing. Now, if the perimeter was 40, what does that mean each side is equal to? So if this side is 8, then this little piece is 4. That's given. Okay, so now, remember on the last, it's half of the side, because perimeter is 40. So every side is 8. Okay, so now we have to think SOHCAHTOA. We have 36 degrees. We have the opposite side is 4. We want to find the adjacent. So this is tangent. So we're going to use tangent of 36 equals 4 over A, or A is equal to 4 over tangent of 36. Now I can't use special triangles. I can't use 30, 60, 90, or 45, 45, 90 because it's a 36-degree angle. So on your calculators, go ahead and plug that in.
5.5.
It gets more difficult, so just 5.5. What we? So we need to plug it, now that we have 40, we have A, we can plug into 1/2 perimeter times the apothem. So basically there's two things you have to look for, perimeter, apothem. Once you know those, just plug it into the formula. What do we get?
1/2.
Times 40 times 5.5. So we get 110, and we had centimeters, so it's going to be square centimeters. There's no such thing as centimeters squared. That's just how people say it. It's a unit. The unit is a square centimeter. If you really want to, you can write it out. Square centimeter. I didn't think so. That's the abbreviation for it. No, you put SQ for square. That's the abbreviation for square. Okay, the area, find the area of a regular hexagon. Each side length is 10, so kind of imagine here's 10, 10, 10, and so on. Oh, good. So we know the perimeter already. That's why I said that you could do the perimeter out of order. So perimeter is 60. So what do we need to figure out? We need to figure out the apothem. Always. Always. For a pentagon. Okay, so what was my step 1? Let's figure out central angle. Good. So central angle is 360 over 6, which is 60. Right? So that means this is 60 degrees. Step 2, we want to draw the apothem.
Oh, so it's 30, 60, 90.
So if I draw the apothem here, that cuts this into 30 and 30 degrees. Now remember, each side was 10, so that makes this 5. So, okay, again. So if you have, now if you're not good with special triangles, it's okay, but sometimes I might ask for the exact answer. Do you remember the special right triangles? If you have a 30, 60, 90, this is x, this is 2x, x root 3. So, yay. So the apothem, does everyone see that it's 5 root 3? So my area, do I have my both things that I need?
Yeah.
It's 1/2. So my exact answer would be 150 root 3 square inches, or somebody wants to give me the approximation. I did. Well, what's 1/2 of half of 60 is 30. 30 times 5. Good. 150 times square root of 3. Did you leave a 0 off or something? I think you left a 0.
I got 21.2.
Wait, what is it?
What'd you get?
21.
Okay, something's weird's going on here. 150 square root.
259.8.
There we go.
Oh,
250.
yeah, I got that list on.
Okay, good? All right, let's move. Okay, so the area of the shaded region, we did this in the one of the last lessons. So the area shaded is the area of the outside region minus the area of the unshaded. So in this case, in this case, we have, what's the outside shape? It's a circle. Okay, do we know the radius of the circle? Yes. So what we want to do is we want to take the area of the circle and we want to subtract the area of the triangle. Right? So pi r squared, so it's going to be pi times 4 squared. Minus, now the area of the triangle is a bit more complicated. There are actually a number of different ways to find it. So 4 is not anything. It's not the height of that triangle. It's not the base of the triangle. It is just a segment. So I'm going to go back to the steps that we had. So first thing I want to do is I want to draw a triangle. Now, what is this angle measure? Well, that's going to be 360 divided by 3, which is, that's my central angle. Now, if that's 120, when I draw the apothem, this is a 30, 60, 90 triangle. Again, just kind of drawn. So here's the apothem. Remember, this is a central angle. So this whole thing would be 120. Cut it in half with the apothem. So if this is 60, this has to be 30. So now, notice how 4 is the hypotenuse in the 30, 60, 90 triangle. So the apothem is 2. Yay. So I'm just going to kind of write this on the side. A is 2. And what is this? Which means the entire side is 4 root 3. Could you figure out then the perimeter? Which would be, so 12 root 3. So even though it's a triangle, I'm not going to use 1/2 base times height. You could, but since I was able to figure out the perimeter and the apothem, I'm going to use that formula, which is fine. So it was 1/2. Perimeter we said was 12 root 3, and the apothem we said was 2. So I get 16 pi minus 12 root 3. So this would be the exact answer. That's as much as you could simplify it. But we'll plug it into our calculator to get the approximation. So if this, do you understand this is 4, this is 2. Oh. Yeah, the 2 and 1/2. It's a, here, do you want? This is, if this is 4, this is 2, this is 2 root 3. Do you see the 30, 60, 90? Does somebody want to tell me a course? Verification? Okay. Sorry, I don't have the solution sometimes. I mean, this is, for this lesson, this is as much, I would say, as difficult as it gets. So, it's not that bad.
Corey was freaking out. Corey told me this, like, this is one of the hardest lessons he's learned all year.
Yeah, it is kind of hard.
Yeah, this is hard.
I don't understand.
But this is because he learned it on bonus. This is so much easier.
I was
than a
trying to
lot of
rush
lessons.
through everything at bonus. I went through it really quickly. So, okay, if you're done with this one, take a look at the next one. See if you can.
The other things that we've done in this class, I think this is fairly.
How are we supposed to know?
Okay, so what do you have in the next picture? We're going to take the area of the square this time, right? And we're going to subtract the area of the circle. Okay, now, here's what I'm going to do. You have to try to create some type of triangle that we can work with. So, yeah, do you want to, there's 2 ways we could do this. Do you want to extend the diagonal, or do you? Because I was just going to go like this. It's always going to be a 45, 45, 90. This is 45. This is 45. So if the hypotenuse is 8 in a 45, 45, 90 triangle, how do you find the side length? Okay, so the hypotenuse you multiply by root 2. So this is 4 root 2. And this would be 4 root 2, which means the entire side length of the square would be 8 root 2. Did I do that too quickly, or are we okay?
So 32 root 2 is
Okay, so now the nice thing about the square, do we have the side? Do I have to do the 1/2 perimeter times apothem for this one? I could just do 8 root 2 times 8 root 2. Do you see that?
Because that how you integrate.
All the sides are 8 root 2. So I could just do 8 root 2 times 8 root 2. If you did 1/2 perimeter times apothem, we're only working with regular polygons for right now. That's why we assumed, that's why we worked with the equilateral triangle in the last one. What's the area of the circle? What's the radius? What's the radius?
Pi 4 root 2 squared.
Good.
It's confusing because it looks like the 8 is really.
Yeah, but it goes past the edge of the circle. Do you see
Oh,
that?
yeah.
8 goes past the edge of the circle, so that's why we just want to use 4 root 2. Okay, so 8 root 2. What do we get? 32 pi? That's it in exact form.
128 minus 32.
Yep. 128.
I have 17 more math classes.
I didn't know that.
I got 102.9.
102.9. Somebody else with a calculator? 102.9?
Let me try.
How do we know that?
Yeah, that sounds too big.
I got 27.4. I know those good. 27.4.
173
Let's double check.
It's 27.5.
I don't know how I got one.
Yeah.
Okay. Perfect.
Oh, units.
I didn't give you units this time, so just units. I don't know, did we miss that? Oh no, the last one was
Wait,
weird.
no, wait, go back up to the answer. Oh my god, this 10 minutes is
Okay, now the next one is not an equilateral triangle in there, but do you see how this is a semicircle? That's 180 degrees. So what kind of angle needs to be here? If it's an inscribed angle, it has to be 90. It has to be half. Do you recognize that? That's from the last chapter. Guys, inscribed angles are half of their arc. So if this is a diameter, then this has to be 180. Okay, this is a 30, 60, 90 triangle. So if this is 5, the hypotenuse would be double 10. Good. Good. 5 root 3. Okay, so my formula for the area this time, what's the outside shape? Okay, so I'm going to take the area of the circle minus the area of the triangle. Good. Do I know the radius for the circle? Has to be 5 because we found that the diameter was 10, so it's going to be pi times 5 squared. Now what about the area of that triangle? Well, let me just redraw the triangle quickly.
Isn't it just 5 times 5 Yeah.
Okay, so I want to show you that we can't use the 10. We have to use the two sides that make the right angle, correct? Because base times height have to be perpendicular. So it's going to be 5 times 5 root 3 over 2, or multiply by half. It's a triangle. Base times height divided by 2, or 1/2. Okay. All right, go ahead and plug that into your calculators.
Or like Monday.
We can even do 2 over times over again. I just have a lot tonight.
Yeah, I went to
do my history homework in that case as well.
What? Did you not start it yet?
56
Jordan, 4 hours?
Thank you very much. Yeah.
It's really easy. It's
The
like
homework that was due last Friday, I turned in yesterday.
56.9? Yay.
Oh, it's 56.9.
Okay.
Oh, I got that.
I'm learning Italian.
That's good.
I want to go to
Okay.
Wait.
All right, guys. Next one, D.
We didn't finish.
Yes, we did.
Yeah, we did.
Okay.
Yeah, we did. Guys,
What kind of shape do we have here?
square, circle, and a pentagon.
Okay, so let's do this. So we're going to we want to take the area of the circle minus the area of the hexagon. Okay, do we have enough information to find the area of the circle? Yeah.
I also know how to find the area of the pentagon.
Okay, if this is 20 all the way across, guys, then each segment to each vertex has to be 10. Good, so that's the radius, so we know pi r squared. Now, what we need to do you remember the central angle? It's going to be 360 divided by the number of sides. So it's 360 divided by 6, 60. So when I draw the apothem, it becomes 30 and 30. So we have a 30, 60, 90 triangle. So if 10 is the hypotenuse, this is 5. Good. So A is 5 root 3. How about the perimeter?
30.
Try again. It's a 30, 60, 90 triangle. Here. The hexagon. Do you see this? So this is 5, this is 10, this is A. Do you see it? So you said this was 60, right? Good. So now it's 1/2 the whole thing. Because what are we trying to find the area of? That's why I put the little names inside. We're finding the area of the hexagon, so we have to use 1/2 perimeter times the apothem. The perimeter is for the hexagon. So we have 100 pi minus 150 root 3, and then what do we get?
No, it's just the way that you said it. You said it was kind of the same sort of width as the guy said it's like one double rainbow over the top.
Okay. What happened? You got it? Okay. The last part I think is actually easier than all the regular polygons. It's just adding up area or using our rule for shaded region. So if you have like multiple shapes, like I'll just show you here, like B, it looks really complicated, but we can break it up into like semicircles and rectangles and then just add up all the areas. But let's look at example 4. So what is the area that's shaded here? How would you find this area? There's a couple ways. You could do the big rectangle minus the little rectangle. Do you want to do that?
Yeah.
Okay, so we're going to do
25 by 150 to the larger water You make a valid point there.
okay. The big rectangle, what are the dimensions? 70 by what? How do you get 150? Can I do it?
No, 150.
Oh, wait, no. 145.
We,
Because you don't know that side.
we don't know this side.
You don't know that. That's why you have to find the large one at the top.
Yeah, you know what? We can't find it this way, can we? We don't have enough information.
We should have more information.
So what we're going to do, hold on.
I'm going to see if we got the same answer when I use the rock.
Okay, let me come back to A then, and let me just do B real quickly. Okay. If this, we'll come back to that one. So if this is,
Yeah.
it's,
Monday.
Here, can I, it's a half.
Guys, it's due tomorrow. Listen, I'm still gonna check it, but if you don't do it, I'm not collecting it tomorrow. So you just lose something, a little cost participation. It's not much, but yeah, if you try it, I'll give you points. Okay, guys, focus. We need to finish, or you guys are gonna be really stuck on this. So if this is 16, this is 8, and this is 8. But you see how these two? Stop talking. If you see that those two semicircles, if we put them together, we'll have one whole circle. So it's going to be pi times 8 squared. Okay, now let's look at the rectangle. Well, we have. Oops, sorry. Okay, now what about this rectangle here? 32 by good. And now what about the triangle? Well, this is 15. Perfect. So we're just going to add all three areas together. There's a right triangle. So base times height.
Oh, see, you're such a. Wait, why is it?
Does that hurt?
Did you get 953.1?
Yeah. You did.
I like this better.
32 times 16 is 512.
I like addition more than subtraction because I don't have to.
Okay, so I did this wrong because I got 1,017.06.
Oh, Miss Kate, I know how to do this. Miss Kate, when I try to do this,
So what's the area of the rectangle?
it's 8 times 10.
Okay.
Okay, and then can I say what's next?
Oh, why did I put square? This was to say triangle. Sorry. I'll go back in a minute. We're out of time. How do we find the height?
Okay, so you cut it in half, so that's 4, and then you do 7.
Yay. So 4. You get about 2 point.
I think we did a good job.
You get 2.06. Pythagorean theorem.
You will rock this homework.
You will rock finals. You will rock finals.
I give you